Hello everyone, this is Rahul Chauhan. I'm going to teach you logic design for this semester. I hope all of you are safe at home. Although I wish to teach you through the offline mode in a more better interactive manner, but somehow the conditions are not favorable, so we have to go for the online mode. Let's hope soon we will be shift to the offline mode. So let me give you an introduction to the subject. In this subject, the subject is divided into five different units. First unit is of the number system, how the number system is generated, what is the significance of number system, what are the different types of number system, and what are the different error detection and correction techniques. Because it is quite often that when we transmit the data or when we communicate the data, there is a possibility of errors. So in your syllabus, you are going to study 2, 3 such techniques. The second unit is of the combinational circuit. Combination circuits are the circuit which are formed by the combination of gates, the logic gates. So we will be discussing the various combination circuits like adder, subtractor, multiplexer, demultiplexer, encoder, decoder. The third unit is of related to the sequential circuit. Sequential circuits are the memory circuits. It's like latch, flip-flop, registers, counters. The fourth unit is of the designing of your sequential circuit and combination circuit, how the different types of combinational and sequential circuits are designed. And the last unit, fifth unit, is the shortest unit. It contains the various properties of integrated circuits, and beside that it also contains the various logic families related to the ECL, TTL, DTL. These are the technique by which the IC is being manufactured. So for today lecture we will be starting with the introduction to the data and the signal. uh, Let us start. Now, to be transmitted, data must be transformed to the electromagnetic signals. So whenever we have any sort of information and we need to communicate it to the some other place, so that information is generally converted into the electromagnetic signals. So this lecture will introduce you what is the data, what is signal, what is the representation of a signal, how signals are represented digitally or analog, what is the amount of power associated with it, and some basic information theory concepts. Now, data can be analog or digital. The term data analog refers to the information that is continuous, and somehow the digital data refers to the information that has discrete values. Analog data take on continuous value, digital data take on discrete value. These are the some general difference between the digital and analog data. Now, the data can be analog or digital. Analog data are continuous and take continuous value, which we studied in the previous slide. And similarly, the digital data have discrete state and take discrete values. Now, what is real number and what is a integer number? Similarly, uh, if I want to give you an example of an analog data, you can take an example of the human voice, the temperature captured by the different type of sensors, the type of signal which we generally generate as a human being through the voice is called a acoustic signal. There are a number of signal associated with our body, and the voice signal is specifically called as the acoustic signal, and it is obviously continuous and analog in nature. So as such, in the complete universe, if we forget about the artificial things, then naturally each and every signal that is existing in the nature, whether by the plants, any sort of structure, humans, everything, every every species on this universe generate a analog signal. Then why the use of and where the digital signal came into light? Generally, the digital signal is associated with the systems. The question is again, what is the need of a digital system? We will be studying in the coming slides what is the significance of digital system and digital signal. Now, I had already told you that signal can be analog or digital. Analog signal can have an infinite number of values in it, and obviously digital signals can have only a limited number of values. You can see it in the coming slide. A simple analog continuous signal in left hand side and a quantized digital signal on the right hand side. Quantized means there is a specific, like you can see that there is a specific level of these signals, one with respect to this value and one with respect to this value. Similarly, there is a negative level associated with this signal. So these are the quantized signal. So digital signal is always quantized, unlike the analog signal, which is having a continuous, a non-uniform structure. They are generally uniform. They have fixed intensity value at a particular band of time. When we see the analog signal, uh, when you check the time instant at a particular time instant, the signal is variable and it has variable amplitude at each and every instant of time. So this is one of the basic difference between the analog and the digital signal. In data communication, we generally prefer periodic analog signal and non-periodic digital signal. You can take an example of AM and FM. These are the analog modulation techniques. Now, the difference between periodic signal and a non-periodic signal. Like a signal which repeat after a fixed interval of time. Like you can see that the difference between this wave and this wave and this wave and this wave is almost the same. That means on x-axis there is a time and on y-axis there is a amplitude value. Now we can observe that the amplitude value repeats after a fixed interval of time. Obviously this is a common sinusoidal wave. Not every analog signal need to be followed the sinusoidal wave. Analog signal can be of any sort of thing. This is just an type of analog signal. Sinusoidal signal, cos signal, tangent, cosine, any sort of continuous signal which is having some value at each and every instant of time is a analog signal. This is periodic analog signal and this is non-periodic analog signal. Similarly, this is periodic digital signal because the fixed interval is repeating each and every time. But this is non-periodic analog signal because you can see that the width of this wave compared to this wave is less. Although the amplitude of both the signal is same, but the width of this one and this one is variable, so it is of non-periodic nature. Now the periodic signal can be classified as simple or composite. You have seen in the previous slide, a simple periodic analog signal is a sine wave. A composite analog signal is composed of multiple sine waves, like you can superimpose 2-3 different sine waves on a single signal. Now let us discuss some properties of a analog signal. Like this is a sine wave. Now try to understand the difference between a signal and a wave. Signal is just of a particular duration. Like if I'm talking about, this is 0 time and this one is 5-second time. Now if I'm saying that the value between 0 to 5. Now this count a complete signal. For a particular time instant, if we are talking about, then that is called a signal. If that signal repeats for a large duration of time, then it become a waveform. Now there are two parameters associated with it. First one is time and second one is frequency. As this one is positive cycle, this one is negative cycle. So time is defined as 1 upon frequency, or you can see that frequency is 1 upon the time. The larger the frequency, lesser the time. Or in a more better way, frequency is the number of repetitions per second. Number of times a signal repeats in a second. Now there are some parameters associated with sine wave. First one is peak amplitude. This is the maximum amplitude, and second one is frequency, and third one is phase. These are some parameters which are generally associated with the sine wave. Peak amplitude is generally related to the maximum amplitude present in the signal or in a waveform. It is generally specified in volts, or obviously it depend upon the system, which system we are explaining through the sine wave. Second parameter is the frequency. I told you earlier that it is related to the 1 upon t. Phase is also one of the important parameter. It give you the position of with respect to the. Now the previous parameters, this is the maximum strength. Although because it is a uniform sine wave, so the peak amplitude repeats at number of time, at this center point, at this center point, this center point, and so on. Now you can see that there are two different sine waves with the same phase and frequency but different amplitude. I told you earlier that frequency and time is represented in this way. Now two signal with same amplitude and phase but with different frequencies. As you can see that during this time, from this point to this time, the number of the repetition of this signal is quite large as compared to this repetition. Although the time remain the same, but the signal repetition time is large. That means the frequency is greater. You can see that the frequency for the signal is 12 Hertz. If we are assuming this as a time period of 1 second, then obviously frequency is 1 upon t, and the time is 1 second, and it repeats the 12 times. So the repetition is 12, or period is 1 upon 12. Similarly, here the repetitions are 6, so frequency is just half as compared to this signal. These are some standard unit. You already have studied all those things in the previous semester. Now you can easily find the frequency or time related to the power supply which is being used in your home. As we know that the frequency of the power supply at our home is 60 Hertz, so we can easily find the time period of a particular signal which is being transmitted through the power in your home, that is 16.6 milliseconds. Similarly, you can check the example. Uh, Obviously, frequency is the rate of change with respect to time, and if it changes very short at a very short duration of time, then you can see that it is having a high frequency. And if it's changing over a long period of time, that means a low frequency. If a signal does not change at all, then it is called as frequency is zero, which is generally we called as DC signal. Phase describe the position waveform related to time. Now you can see that the three sine wave having the same frequency and same amplitude, but they are having the same different phase. Why? Because this sine wave start with the 0, this sine wave start before the 0 at 1 by 4t, and this sine wave start at 1 by 2 of t. So there is a phase difference between all these waves. Similarly, you can see an example. A frequency domain is more compact and useful when we are dealing with more and more number of sine wave, as it will clearly give you an example explanation how the different signals are being segmented. An amplitude frequency phase curve will give you a clear separation. You can see the right hand side. It is quite difficult to analyze such type of multiple sine wave when we are taking the time and the amplitude curve. But when we take a curve of amplitude versus frequency, then it is obviously it is very helpful for us to differentiate between the different types of signal. So it totally depend upon your system or the type of system which you are using, whether we need to go for the amplitude versus time curve or we need to go for the amplitude versus frequency curve. Obviously, a single frequency sine wave is not useful in data communication. We need to send a composite signal, a signal made of many simple sine wave. Now, there is a thing called Fourier transform, which is generally used to transform any signal which is given in time domain into the frequency domain. Now you can see the time and frequency domain of non-periodic signal. The bandwidth of composition difference between the highest and the lowest frequencies. Now you can see that digital signals. Now let's go to the digital signal, which is actually the main part of our subject. What is the need of digital? Digital is not just about a value of 0 or 1. Moreover, it is the representation of a into a continuous curve into a, like we have a sine wave, right? You can see that at from this point to this point there are if we choose at any instant of time, if this is time domain, then you can say that there is always a value associated with it. There is always an amplitude value associated with it. But when we talk about the digital system, it has a fixed finite value. That means if I am talking about from this time to this time, half of the total time, then it must have a fixed amplitude value, not a variable value. And it is sometimes required. The reason is when we need to store the value, when we need to store the information, obviously we are available with the analog information, but it is quite difficult and it is also bulky to store the analog information. You might have heard about the floppy disk, CD, DVD, all these are the analog storage devices. So there is a proper bulky device and a limited storage capacity. So we come with a more advanced technology, that is digital storage. Now digital storage, what we did is we quantize these signal into some levels. If we quantize those levels into only two level, either if this is high and this is 0, forget about the negative value. If this is high, this is 0, then there are two level, high value and low value. So what I am doing is I'm just quantizing my information in high and low. So that high value can be represented by any digital representer, and similarly low value can be represented by any digital representer. So in digital system, that high value representer is generally 1 and low value representer is generally 0. Fine. Similarly, if we quantize this information at 4 different level, then we can have 4 different such level. You can name them 0, 1, 2, 3. If we represent them in 8 different level, then you call it as octa number system. The number system came into the picture when we have 8, 4, 8, 16 and such number of different levels which we are actually going to quantize. So the type of number system is definitely dependent upon your quantization level, right? Like if you have 8 quantization level, you name it as octal number system. If we have 16 quantization level, you name it as hexadecimal number system. Similarly, if we have 2 quantization level, that is 1 and 0, then you can name it as digital number system. So in the coming lecture, I will be teaching you about the representation of different type of number system.